4b, so one of the first questions is, why do we divide by n in the APR over n in the compound interest formula? Well, n is how many times a year you get your interest. So if you're getting it monthly, then you don't get the full annual percentage interest rate. You only get a twelfth of it each month. And so you're dividing by it because you want to know how much interest you get for that period. And so if you're only getting your interest added every 12 times a year, then you should only get a twelfth of the interest rate. And that's why you would divide by n. And what is APY, annual percentage yield? Now that's equal to the APR for simple and compounded annually. But if you're getting your interest added more than just once a year, then you're going to get a little bit of interest, and then you're going to get interest on that interest and interest on that interest. And so each pay period, or each period that you get your interest compounded in, added to your principal, then you start getting interest on the interest, and it produces a higher yield than you would get if you just did the interest for the full year. So that's what APY, why it's bigger. Now we got some math problems here that some of you are having trouble with. Now you can actually just type this in, but I want to also explain what is going on here. So if we have 64 to the, and normally if on a regular calculator you want to put this in parentheses, I would go -1 divided by 3, close parenthesis for my exponent, and enter, and I get 0.25, which is 1/4. Now, how does this come out to be 1/4? Well, first of all, a negative on the exponent means we're dividing. So this is really 1/64 to the 1/3. Now, 1/64, or 64 to the 1/3, this is the cube root. It's saying what times itself 3 times makes 64. Well, 64 is 8 times 8, you know that, I hope. And so that is 2 times 2 times 2 times 2 times 2 times 2. So what times itself 3 times and makes 64? Well, a pair of 2's times a pair of 2's times a pair of 2's would make 64. So 4, 2 times 2, 4 times itself 3 times, 4 times 4 times 4 is 64. Okay, that's why it comes out 1/4. Now 36 is an old Algebra 1 problem, one of the more complicated ones. We want to get our variables all collected on one side, so we would add, I would add 4s. You could subtract 6s, but I'm going to add 4s because I like to keep things positive. And so I get 10s. I do these because they looks like a 5 or a 2 or something, gets confusing. So I add those little marks on there. And then I would get the constant to the other side by going +5 and +5, and I get 10 equals 10s, and that's time, so I divide by 10, and I get s equals 1. That should look familiar to you. This one, because it's like 2/3 x, that bothers people, but it's still like, it's just a number. So I would subtract 2/3 x from both sides. So I have 4 equals, now 2 x's minus 2/3 of an x, I would need to get common denominator. 2 is 6/3, so 6/3 of an x minus 2/3 of an x is 4/3 x. Now to finish solving for x, this x is times a 4 divided by 3, so we do the opposite. Times a 3 divided by a 4. Times a 3 divided by 4. So 4 divided by 4 is 1, times 3 is 3, equals x. All right, if I want to get rid of the third power, the y to the third, I'm looking for something that I can take times itself 3 times to make 27. You might be able to do that in your head. If you can't, you can also just do 1/3. And when you have something to a power, you multiply the powers, and that's why I used 1/3. 1/3 times 3 is 1, so I get y to the 1, or just y, equals 27 to the 1/3. So that's saying what times is 3 itself? 3 times makes 27, and let's just ask the calculator to do that. 27 to the 1 divided by 3. And it says it's 3. All right. What do I do to get rid of the 1/3 power? Well, I would take it to the 3 power. And 1/3 times 3 is 1, so I get P equals 3 to the 3rd, and that doesn't mean 3 times 3, that means multiply 3 3s. So that's 3 times 3, which is 9 times 3, 27. This one, if you subtract 2 from both sides, we get w squared equals 25. And a lot of you think of this as square root. We could also do the half power to get rid of the 2. Or take the square root, and we get w equals, there's a trick on this one though. There's more than one answer. Both a 5 and a -5 multiplied times itself. 5 times 5 is 25, and -5 times -5 is 25. So there's 2 answers to that one. Now we go to 50. We subtract 4 from both sides, and we get v to the 3rd equals 64. And then we can take the cube root, or 1/3 power of both sides. 1/3 times 3 is 1, so v equals, and the cube root of 64, we've already kind of figured that out as 4. But we could also type it into the calculator. 64 to the 1 divided by 3 power 4. Okay. So our compound interest formula is the amount after some times is the principal, the amount we put in, times 1 plus the APR divided by N to the N times Y. So following the formula, we deposit, so that's our principal, 3201 plus our interest rate. Now to do this, I'm just going to work this out, is going to be 0.035. Do not forget to change your percent to decimal. And then we're doing it annually, so divided by 1. Annually means once a year, so these n's are 1s. So this is going to be 0.035 to the 1 times 5 is 5. Now to work that out on the calculator, I get this answer plus 1. There's this. Take it to the 5, and I get that and then I take it times 3200, and I get 3,860 cents. Now we're going to do another one of these. So it's going to be 3,000 parenthesis 1 plus compounded annually. So this as a decimal is 0.018 divided by 1 to the 1 times 12. So divided by 1 doesn't change it, so I'm going to have 1.018 is what this inside would be. I'm going to take that to the 12th, and I get a number that I'm going to take times the 3,000, and I get $3,716.16, rounded to the nearest penny. Okay, now we're going to do 10,000, 10 years, 2% quarterly. So 10,000, 1 plus 0.02 divided by quarterly, 4 times a year, 4 times 10. So I'm going to do 0.02 divided by 4 plus the 1. That's this piece, to the 40th power. And that tells me what I need to multiply that by, times 10,000. And I get 12207.94 cents. Okay, again 10,000. This time the interest rate is 0.0275. We're doing this one monthly, and so I got to take it to the 12 times how many years? 5. And so again, we'll do the 0.0275 divided by 12, add the 1, take that to the power of, I'm going to put parenthesis, 12 times 5. That's 60 if you want to do it in your head, but I'm just going to do it. And that's what I need to take times 10,000. And I end up with 11472.21. Okay, we got another one. We're going to do monthly, the APY. Now, it doesn't give us amount to start with. We really don't need to know that. We really need to know what this multiplier would be. So, some amount, and it's going to be 1 plus the APR, which is 0.032 over monthly 12. We have to do this 12 times 1 year, because we're finding the annual percentage yield. So annual means 1 year. That's why we're doing 1 there. So I'm going to work that out. So I have 0.032 divided by 12, add the 1, take it to the 12 months, not 13, 12. And now the yield is going to be the percentage besides the 100%. So subtract the 1 off again, and that's my yield if I take it times 100. And my annual percentage yield is 3.2473%. 74%. Okay? Now let's do this one. The yield when it's 2.25% quarterly. So we're going to do, we don't care how much, it's 1 plus 0.0225 divided by quarterly 4 times. So 4 times 1 year, because we're getting the annual percentage yield. So we'll do 0.0225 divided by 4 plus 1 to the power of 4, because 4 times in a year. Now the annual percentage yield is the decimal part of this. Get rid of the 100%, minus 1. So it's going to be, if I change it to percent, it's going to be 2.269% is the annual percentage yield. Now we're supposed to figure out how much 7,000 will turn to if it's compounded continuously. So your compounded continuously formulas is the amount you have later is how much you start with, e to the APR times the number of years. And so 77, so it's $7,000 is the P, e to the 0.045, you always use the decimal form of this, times, now are we just getting the annual percentage yield, or actually, let's see here, 77. We're supposed to do it for 1, 5, and 20 years, and get the annual percentage yield. Okay, so let's do it with 1. So we have 7,000. Put it over here so you can see it. Second e to the parenthesis 0.045 times 1. Enter. And so for 1 year, it's 7322.120, I guess. For 5 years, I would go back and change the 1 to a 5. Second, enter on a TI calculator. It'll let us go back there. 5, enter, and that's 5 years. It's 8766.26. And then 20 years, we'll go back and change the 5 to a 20. Second, enter, or I can arrow up, but I can just put 20, close parenthesis, enter, and I get $17,217.22. Now, what's the APY? Well, we can go with the 1 year because that's what it's about. So how much did we increase by? We went from 7,000 to $7,322.20. So that went up by $322.20 divided by what we started with, 7,000. This is one way to do it. And we get an APY of 322.20 divided by 7,000 times 100 to make it a percent. And we got a, did I get too many zeros? I did 70,000. Whoop, I wondered there. Second enter, go back here, take off 1 0, enter, times 100. We get an annual percentage yield of 4.6%. The other way to do that is similar to the way we were doing it up here. Forget how much we started about, just look at this part. So that would be e to the 0.045 times 1 for 1 year, and subtract the 1, and we get times 100, and we get the 4.6027% yield. Okay. 80. Supposed to do the same kinds of things. So we're going to have 500 e to the amount after some time would be 500 e to the 0.027 times the number of years. So we're going to have 500 e to the parenthesis 0.027 times 1 for 1 year, 513.68. For 5 years, second enter, go, oh, change that to 572.27. 572.27 and 20 years. Second enter, go back and change the 5 to a 20. $858.00. Okay, and the annual percentage yield. Again, we could take how much we gained, 500 to 513.68. That's 13.68 divided by 500. And that's 2.736%. The annual percentage yield is 2.736%. I can also get that by forgetting the 500 and just saying e to the interest rate 0.027 times 1 for 1 year, which is that already. Subtract the 1 and we get that percentage rate, 2.7367. So 68 actually, but yeah. There's the answers to this one. And now we want to do one problem where they want us to work backwards. They want to end up with this, and we're compounding monthly, so that's the original formula. We want to end up with 120,000, starting with some amount. We don't know, that's what we're supposed to find. 1 plus the APR, 0.035, monthly, 12, 12 times, they want to do it in 15 years, have that much money. How much do we have to start with? So I'm going to work out this number. I'm going to go 0.035 divided by 12, add the 1, take that to the power of 12 times 15, close parenthesis, and so the multiplier here is 1.689167,595, and that's times what I need to start with to end up with this, so I divide both sides by that. So I'm going to take 120,000 divided by that last answer, second negative, enter, and it says I need to be able to put $71,040.91 into an account at 3.5% for 15 years, compounded monthly, and it'll end up with $120,000. Okay.